Global Warming 50 Years Hence, a tribute to Wally Broecker. Imagine it is 50 years ago, 1974. The Beatles broke up in 1974. Richard Nixon resigned the presidency. The Sears Tower in Chicago was finished, becoming the highest building in the world. A 55-mile-per-hour speed limit was imposed on the country to save gas. Most of us weren't thinking about changes in global temperatures. I suspect Wally Broecker, a geochemistry professor at Lamont Doherty, was. In fact, he was probably finishing up what would be one of the most famous scientific papers in the world. A year later, in 1975, Wally Broecker published a paper in the esteemed journal Science entitled, "Climate Change, Are We on the Brink of a Pronounced Global Warming?" That paper was the first to use the term global warming. In that paper, he states the exponential rise in the atmospheric carbon dioxide content will have driven the mean planetary temperature beyond the limits experienced during the past 1,000 years. In writing this paper and his subsequent work, Wally Broecker became known as the father of global warming or global climate change. It's useful to look back on this work and on the predictions he made regarding global warming 50 years ago. Wally Broecker, in this statement above, proposed a theory of global warming based on the rise of atmospheric CO2 levels owing to the burning of fossil fuels. Again, he proposed a theory, and theories are testable. But how can you prove a theory? One way to prove a theory is to make a prediction and then test whether it comes true. The prediction can't be arbitrary. For example, I could say, I will roll 2 sixes using these dice. If I then roll 2 sixes, nobody would say that I proved my statement because my prediction was arbitrary. There needs to be a reason that something occurs to prove a theory, a cause. Let us now consider Broecker's theory of global warming and reconstruct his thought process with the goal of testing whether he has proved global warming based on data currently available, and that this proof is not arbitrary. Broecker specifically predicts that from the rise in atmospheric CO2 from burning fossil fuels will cause the global temperature to rise. He's saying that global temperatures are linked to changes in atmospheric CO2 levels. It had been well known for decades that by adding CO2 to the atmosphere through the burning of fossil fuels, heat is trapped and temperatures rise. This idea had been proposed by the Swedish scientist Arrhenius in 1896, who predicted that changes in atmospheric CO2 levels caused by human industrial activity could substantially alter temperatures through the greenhouse effect. Dave Keeling started making consistent, precise, and periodic measurements of global atmospheric CO2 concentrations in 1959 on Hawaii and showed there was a clear increase in values with time. In 1959, Keeling measured the atmospheric CO2 level at 316 parts per million, but it was 331 parts per million by 1975, a 5% rise. Clearly, atmospheric CO2 was rising with time and had been linked to the burning of fossil fuels. Wally Broecker knew about Keeling's work and wondered if he could predict future global temperatures based solely on atmospheric CO2 data. But first he needed to predict atmospheric CO2 values into the future. So in his 1975 paper, he extrapolated the Keeling data to predict atmospheric CO2 values to the year 2010, and his prediction is shown here in Figure 1. The blue dotted line in Figure 1 is the Keeling data that Broecker had available to extrapolate from 1959 to 1975, and he's going to predict out values to 2010. The orange line and the points are his prediction of future atmospheric values. This is the orange line. Because nearly 50 years have elapsed since he made this prediction, we can now compare his predicted CO2 values, shown in orange, with the actual data shown in gray, as also depicted in Figure 1. His prediction of CO2 was relatively accurate until about the year 2000, so the gray and the orange lines are coexisting until the year 2000. And then after 2000, his prediction was too high relative to the actual data. Next, Broecker had to predict temperatures into the future beyond 1975 when he wrote his paper based on his atmospheric CO2 extrapolation. In Figure 2, a plot of smooth surface temperatures from NASA is shown for the 50 years prior to 1975. So here's 1975, and this is NASA's smooth surface temperatures 50 years prior to that, to 1925. Although there are clearly some deviations in global surface temperatures, in general, the overall trend from 1940 to 1975 is a slight decrease in global temperature and perhaps a modest increase in global temperature from 1925 to 1975. However, Broecker predicts what appears to be an enormous increase in temperature over the next 50 years relative to the past 50 years, caused by what he calls chemical fuels combustion, the burning of fossil fuels like coal, gas, and oil. Doesn't this look nuts? This is the past 50 years. This is what Broecker's predicting. It looks crazy. Given that approximately 50 years have elapsed since the publication of his paper, we can now look back and assess how accurate his prediction was and decide whether he's proven his theory. Let's say it's 1975 and you're asked to evaluate Broecker's prediction of global temperature over the next 50 years. So you're right here. You were asked the question, which changes in global temperature would prove that Broecker's prediction was correct? Curve A, B, C, D, E, or F? Certainly not curves A, B, and C. Maybe D. Certainly E would be substantial proof that Broecker was correct, and we're not really sure about F. So before we actually look at the data, we state if the actual data look like curve E, here's curve E, in Figure 3, we'll believe that Broecker has proved global warming. Okay, the deal is if the results look like curve E, we say, okay, you've done it, you've predicted and proved global climate change. That's our deal. In Figure 4, I have extended the measured global surface temperatures, again from NASA, out to the present as red dots. Here are the red dots. So this is the actual data from NASA up to 2023. What is immediately striking is how closely Broecker's proposed data, shown in orange, is to the, shown on the orange line, is to the actual data shown with the red dots. It looks pretty much like curve E in Figure 3, doesn't it? Recall that Broecker's predicted temperature is based on his prediction of the rise in atmospheric CO2 with time based on extrapolating the Keeling curve. Although close, he overestimated the parameter after the year 2000. For example, in 2010, Broecker predicted atmospheric CO2 to be 403 parts per million, but instead it turned out to be 390 parts per million. This raises the question as to what Broecker's predicted temperatures would be had he perfectly predicted atmospheric CO2 over time. To address this concern, also shown in Figure 4 is my recalculation of the Broecker predicted temperature data using actual atmospheric data. That's this purple line here. That's the purple line, and it shows what Broecker would have predicted had he perfectly predicted CO2 atmospheric data. And of course, shown on Figure 4, there's even a better apparent correlation between predicted temperature, shown in purple, and the observed temperature, shown in red. Actually, on Figure 4, the current global temperature is a little bit higher than Broecker would have predicted. So the red dots are above the purple dots. What can be learned from this exercise? First, it seems that Broecker's proposed theory of global warming is proven by our previous argument. His predicted temperature rise is not exactly like the smooth NASA global surface data, but the two curves look remarkably similar. After replacing Broecker's predicted CO2 data with actual measured CO2 data, as shown with the purple line, our friend the purple line here, in Figure 4, the correspondence becomes even stronger. It's also useful to remember the initial situation in 1975, as shown down here in Figure 1, and how crazy his prediction looked. It's simply amazing to see what confirmation of his theory would look outrageous at the time in 1975 relative to the past history from 1925 to 1975. Finally, remember that we were concerned that we had proven the theory was not proven by an arbitrary premise. In Broecker's case, the rise in temperature was predicted through the rise in atmospheric CO2. This proof was not arbitrary. This was no accidental roll of the dice. From what was written above, Wally Broecker sounds like a lone wolf back in 1975 proposing an easily ridiculed theory to a world who just didn't care. But this wasn't the case at all. As I noted previously, scientists had been predicting global warming for nearly a century prior to Broecker's landmark paper, and they continued to do so after his paper was published. In Figure 5, I show just a few of the more famous predictions of the rise in global temperatures associated with the burning of fossil fuels and associated human activities that lead to global climate change. The Russian scientist Budyko proposed a similar theory of global warming in 1972. The work was in Russian and less visible to Western scientists. So here's Budyko's prediction, shown as a dashed line, and it's pretty similar to Broecker's and the actual outcomes. Hansen and co-workers provided another prediction of global temperatures in 1981, very similar to Broecker's. With time, the International Panel on Climate Change, the IPCC, was created and provided a number of predictions of climate change. Broecker had only provided a single prediction for the increase in global temperatures, whereas subsequent studies provided a range of outcomes based on considerations of additional factors and uncertainties. Everybody predicted the same general increase in global temperatures, the point being that Broecker's prediction was not at all out of line with the thinking of his peers. He just did it earlier and nailed the term global warming. From what was written above, it seems like everybody's in agreement. Global warming and global climate change exist. But of course, that isn't right. Fortunately for us, there have been some folks known as deniers who have provided alternative predictions of future global temperatures, and these are shown in Figure 6. Don Easterbrook, a professor of geology at Western Washington University, argued that current global warming is part of a natural cyclic event, and he provides us with two predictions that he made in 1999 that don't look very good. Comparing Easterbrook's predicted global temperatures to observed global temperatures since he made his predictions compels us to disregard his hypothesis, however. Richard Lindzen gave a presentation at MIT in 1989 in which he provided his own predictions of future global temperatures. The predicted temperatures of Lindzen, shown in Figure 6, are not his work, but are work from another climate scientist trying to emulate his work. So, how could these results be challenged? How could anyone claim that global warming isn't proven? There have been concerns about the effect of urban heat islands caused by cities covered with cement and tar, raising temperatures with time, and of course the older thermometer data could also be challenged. However, these concerns have been addressed by a large number of ad hoc studies that suggest minimal impact. At this point, given half a century of time has now elapsed, we must consider the theory proven. Remember our previous agreement, if it's curve E, it simply must be. What are the implications of this global climate change? Unfortunately, this is not known with any certainty. Yes, it's likely that the glaciers will melt more rapidly, that the poles will lose their sea ice, and the sea levels will rise, but at rates that are much more difficult to accurately quantify. There are many additional uncertainties, especially concerning changes in weather patterns, intensity of storms, and occurrence of droughts, many of which are currently experiencing today. To put it simply, we really don't know what the future holds, and that's a concern. The Earth has not seen CO2 values like those today for at least 800,000 years, and the best comparisons are of an Earth about 55 million years ago. So we simply don't know what is going to happen, and global uncertainty is frightening. Roger Revelle summarized his concerns about global warming before global warming was even a term in this quote from 1957. Human beings are now carrying out a large-scale geophysical experiment of a kind that could not have happened in the past, nor be reproduced in the future. Within a few centuries, we are returning to the atmosphere and oceans the concentrated organic carbon stored in sedimentary rocks over hundreds of millions of years. This experiment, if adequately documented, may yield a far-reaching insight into the processes determining weather and climate. So welcome to our large-scale geophysical experiment. This is where I got my data for NASA, and this is, of course, the Keeling curve.